Right now, as you're watching this, something is happening in our solar system that should not exist, and the closer scientists look, the more impossible it becomes. It's April 11th, 2026, and just 14 hours ago, NASA's Deep Space Network recorded an event linked to 3I Atlas with only a 0.0014% probability of being natural. That number alone should make you pause, because what they detected wasn't just another anomaly. It was a coherent, visible photonic bridge, a perfectly directed stream of ionized particles and electromagnetic radiation stretching across space between Earth's orbit and the current path of Mars. Picture that clearly: an interstellar object, believed to be nothing more than a rogue comet drifting through space, suddenly emitting a focused beam of glowing plasma. Not scattered, not fading. A straight, controlled structure, extending across millions of kilometers. This is not something pushed randomly by solar winds. This level of precision demands control, and control suggests intention. When you look at the data, the physics becomes deeply unsettling. Comets simply do not behave like this. In decades of theoretical physics and astrophysical modeling, including complex frameworks that attempt to describe the universe at its deepest level, nothing has matched this kind of observation. The James Webb Space Telescope, using its NIRCam instrument, first captured the anomaly at exactly 1842 UTC. What it recorded was a massive surge of energy equivalent to 33 billion tons of ionized material channeled into a perfectly defined cylindrical beam. And here's what makes it even harder to explain. The beam does not spread out, it doesn't weaken. It holds a constant diameter of exactly 87.63 kilometers across a distance that spans millions of kilometers through empty space. If you zoom out and imagine this on a cosmic scale, it looks like a glowing tether connecting two planetary orbits, Earth and Mars, like a bridge drawn with absolute precision across the void. The energy required to maintain that kind of structure goes far beyond what our current thermodynamic models allow. And while this is unfolding, observatories across the planet are rapidly redirecting their instruments to capture every possible detail. Because this bridge isn't stable in a passive way, it's active. It pulses with energy in repeating sequences, and those sequences are not random. They follow prime numbers. That detail alone changes everything. Even the most cautious researchers at NASA's Jet Propulsion Laboratory have expressed concern. When institutions of that scale activate emergency classification protocols, it's a sign that something fundamental is being challenged. The official explanation suggests a rare, highly energetic outgassing event, but that explanation struggles to account for the level of order we're seeing. Let's put this into perspective. For a natural process to create a plasma beam with less than 0.03 degrees of deviation across 240 million kilometers would be like hitting a moving grain of sand with a laser from the moon. It's not just unlikely, it's effectively impossible. And yet, it's happening. Before we go deeper into the physics of this luminous structure, we need to understand the object behind it. 3I. Atlas was first discovered on August 12, 2025, by the Atlas Survey System and classified as the third known interstellar object to enter our solar system, following earlier discoveries like Oumuamua and Borisov. At first, it seemed like just another visitor, but almost immediately, something stood out. Its core temperature measured at 142 Kelvin, far warmer than expected for an object so far from the Sunday. That single detail triggered alerts across major observatories worldwide. For months, it behaved mostly within expectations, aside from that anomaly. Then everything changed. On April 6, 2026, at exactly 3:14 UTC, the first major event occurred. NASA's Deep Space Network detected a sudden electromagnetic burst coming directly from the object's core. At the same time, the James Webb Space Telescope recorded the first formation of the photonic bridge. This wasn't a single observation. ESA's Gaia spacecraft independently confirmed the same light curve anomaly. The ALMA array in Chile verified the frequency signatures using a completely different method. 3 independent systems, 3 different approaches, 1 identical result. That level of agreement leaves very little room for doubt. Here's what that means. Nearly all known comets, about 99.98%, release gas randomly as they heat up. They do not emit tightly controlled beams of continuous energy. To sustain a plasma structure like this, you would need a powerful magnetic containment field, and the chance of that forming naturally is around 1 in 4.7 billion. At first, scientists assumed this was a rare, one-time discharge. They were wrong, because on April 7th, the beam didn't fade, it extended. It grew to 12.4 million kilometers, aligning precisely with the orbital path of Mars. The level of accuracy required to target a moving planet from that distance is staggering. The beam maintained a steady velocity, 0.8% the speed of light, without deviation. That's like trying to hit a speeding bullet with another bullet while blindfolded. And yet, the system held perfectly. Then came April 8th. Spectroscopic analysis from the Hubble Space Telescope revealed something even more unexpected. The beam wasn't composed of simple ionized gas. It contained heavy metallic elements, strontium, barium, and unusual titanium isotopes, materials that should not behave this way at such low temperatures. The structure was acting like a massive conductive wire, holding its form in a stable plasma state. At this point, scientists have identified 7 distinct anomalies within this single phenomenon. What stands out most is how strongly this system opposes entropy. In nature, things spread out. They become disordered. But this structure is doing the opposite. It is organizing perfectly. Imagine seeing a bolt of lightning frozen in the sky for days, completely straight, completely stable, and then scale that up to a cosmic level. The amount of material needed to sustain a beam, 87.63 kilometers wide, over such a distance, is enormous. Calculations suggest the object would need to consume 400,000 tons of mass every second to maintain it. But here's the problem. It isn't losing mass. Measurements show a decrease of only 0.001%, so the energy is coming from somewhere else. And that raises a question we can't ignore. Where is it coming from? Because when even leading astrophysicists admit that this behavior doesn't fit any known model, we are forced to consider a different possibility. This may not be a natural object at all. And what scientists discovered inside that beam is even harder to explain. If the existence of the plasma bridge itself wasn't enough to challenge everything we understand about physics, what scientists discovered next takes this far beyond a simple anomaly. Because the beam isn't just there. It's doing something. Let's continue exactly where we left off. At first, researchers focused on the structure of the bridge, its stability, its composition, its impossible precision. But as more data came in, attention shifted from the outside of the beam to what was happening inside it, and that's when things started to escalate. From a relativistic standpoint, transmitting a coherent stream of plasma across 240 million kilometers is already beyond our current understanding. In a vacuum, ionized particles should repel each other instantly. Without a containment field, the beam should collapse into a diffuse cloud in seconds. But that's not what we're seeing. Instead, the bridge remains perfectly intact, tight, stable, and sharply defined across its entire length. The closest comparison would be trying to shoot a stream of water across an ocean without a single drop breaking away. It doesn't happen in nature, and yet this structure holds. For years, physicists have relied on the principle that systems tend toward disorder. Energy spreads out, structures break down, But this bridge is doing the opposite. It's maintaining order rigid, precise, and sustained over time. Then, on April 9, 2026, at exactly 14:22 UTC, something changed. NASA's Deep Space Network detected a sudden fluctuation in the beam's energy output. This wasn't predicted. It wasn't part of any existing model. The bridge began to pulse. At first, it seemed irregular, but as the data was analyzed more closely, a pattern emerged. The pulses were rhythmic. That alone is unusual, but what makes it extraordinary is how precise those rhythms are. NASA confirmed the pattern at 14:25 UTC. Just 3 minutes later, ESA's Gaia spacecraft independently verified the same anomaly. Then ALMA in Chile cross-referenced the signal using its own instruments. 3 separate systems, 3 independent confirmations, 1 identical conclusion. The beam is pulsing at mathematically precise intervals. Let's put that into perspective. The probability of a comet generating a focused plasma beam is already extremely low, around 0.0014%. But the probability of that same object producing perfectly timed pulses within that beam drops to less than 1 in 84 trillion. That's not just rare. That's statistically beyond expectation. Across millions of years of observation and thousands of known objects, we have never recorded anything like this combination of behaviors. Now, imagine what scientists are seeing on their screens. Instead of a blurry cloud of gas, they're looking at a sharp, geometric line stretching through space connecting Earth's orbital plane to Mars, flashing in controlled intervals like a distant lighthouse. And those intervals aren't random. This is where the situation becomes extremely difficult to explain using natural processes. Prime numbers are not something you expect to find in chaotic astrophysical systems. They require counting, sequencing, organization. In other words, they require a system capable of processing information. And that realization has started to shift the conversation. Because now, the question isn't just, what is this object doing? The question is, why is it doing it with this level of precision? Even senior figures within major space agencies have begun to acknowledge that this behavior violates fundamental thermodynamic expectations. When someone with decades of experience publicly states that our current models are failing, it signals something important. The framework we rely on to explain the universe may not be enough. And yet, the data keeps coming. When scientists calculated the energy required to maintain this beam, the numbers became even more difficult to accept. The output is roughly equivalent to the total electrical energy produced on Earth over 10,000 years, compressed into a single, continuous stream. And the object producing this energy? It's only about 4.2 kilometers in diameter. That doesn't add up. There isn't enough mass to sustain nuclear reactions at that scale. There isn't enough material to explain the output, which means one of 2 things must be true. Either we are missing a fundamental piece of physics, or the energy is being drawn from somewhere else entirely. Some researchers have proposed that the object could be tapping into zero-point energy, the baseline energy present in the quantum vacuum. Others have suggested the possibility of an internal microsingularity acting as a power source. At this stage, these ideas are speculative, but they are being taken seriously because the data demands an explanation. Then came another critical observation. ESA's Gaia spacecraft detected a slight but measurable shift in the object's trajectory about 0.08 degrees. That might sound small, but at this scale, it's significant. It means the object adjusted its path deliberately. And when scientists compared that adjustment to the alignment of the beam, the conclusion became clear. 3. Atlas is maintaining alignment with Mars. Let that sink in. It is tracking a moving planetary body across millions of kilometers of space with near-perfect accuracy. That's not drift. That's control. A natural object does not steer itself with that level of precision. When this data was first reviewed, it was checked multiple times to rule out error. But the results held. The object is actively correcting its course. And as this is happening, the pulse rate of the beam is increasing. At 36 hours before the closest alignment between Earth and Mars, the pulses occurred every 23 seconds. At 24 hours, the interval dropped to 11 seconds. At 12 hours, the pattern shifted again, this time following prime number intervals. This is not random behavior. It is structured, evolving, and consistent with a system adjusting itself in real time. Now, here's where things take another turn. Some physicists have proposed that what we're seeing may not be a traditional beam at all. Instead, it could be a visible effect of space-time distortion, a localized pathway forming between two gravitational points. If that's true, then the light we see could be a byproduct of exotic interactions similar to Cherenkov radiation, occurring as energy moves through a modified region of space. But even that explanation doesn't fully account for the precision we're observing, because what happens next changes the focus entirely. Up until now, we've been looking at the bridge itself, its structure, its energy, its behavior. But the bridge may not be the main event, because scientists have now detected something inside it, something moving, something massive. And what that means is far more difficult to explain than the bridge itself. Up to this point, everything we've analyzed has focused on the structure of the plasma bridge itself, its stability, its precision, and its impossible energy behavior. But now, the attention of scientists has shifted away from the beam and toward something inside it, because the bridge is no longer just a structure. It is carrying something. Let's continue exactly where we left off. After the rhythmic pulsing of the beam was confirmed and its prime number sequence identified, researchers expected the system to remain stable. Instead, new data began to emerge from deep space tracking arrays that changed the entire interpretation of the phenomenon. Inside the plasma bridge, instruments detected a concentrated cluster of mass, not scattered particles, not background interference, a defined object. According to mid-infrared readings from the James Webb Space Telescope, this mass is estimated at approximately 12,000 metric tons. That figure alone is staggering, but what makes it more significant is what it's doing. It is moving, and not randomly. It is accelerating through the plasma bridge at approximately 4.2% the speed of light, traveling in a direct trajectory toward Mars. Pause and think about that. A massive object, embedded within a structured energy beam, is being transported across interplanetary space at relativistic speed. That is not something we have ever observed in natural astrophysical systems. The implications are immediate and deeply unsettling, because if this is a natural outgassing process or a byproduct of cometary activity, then the physics involved would break under simple gravitational and inertial constraints. A 12,000-ton mass cannot simply be suspended in a plasma stream without losing coherence, dispersing, or collapsing under external forces. And yet, it remains intact. More than intact, it is being guided. That realization has shifted the interpretation across multiple scientific teams, because the bridge is no longer being treated as just an emission structure. It is now being analyzed as a possible transit corridor, a pathway, a directed channel of energy and matter. And what makes this even more complex is how the mass is behaving inside it. Tracking data shows that the object is not drifting within the beam. It is accelerating in response to the pulsing intervals detected earlier. Each pulse, each precisely timed electromagnetic burst, appears to correlate with incremental increases in velocity. In other words, the pulses are not just signals, they are influence points. This suggests that the beam is not simply carrying energy outward, it is actively controlling motion within itself. And that changes everything, because now we are not just looking at a plasma structure. We are looking at a system capable of propulsion, synchronization, and directional transport across millions of kilometers. To understand how extraordinary this is, imagine a tunnel made of pure light stretching across space. Now imagine something inside that tunnel being pushed forward, not by inertia or gravity, but by rhythmic energy pulses embedded within the tunnel itself. That is what the data suggests is happening here. And it raises a question scientists are increasingly reluctant to ignore. If the bridge is controlling motion inside it, then what is controlling the bridge? At this point, multiple agencies began re-examining the system as a whole rather than as separate anomalies. NASA, ESA, and independent observatories cross-referenced their data streams, and the results aligned perfectly. The mass is not simply moving, it is being accelerated, and the acceleration matches the timing of the pulses with near-perfect consistency. That level of coordination suggests a unified mechanism, something orchestrated rather than emergent. Then came another critical development. Within 45 minutes of confirming the moving mass, NASA initiated a Level 1 deep space data blackout for civilian observatories using the Deep Space Network. That level of restriction is extremely rare, and historically, it has only been used when data is considered potentially destabilizing or misinterpreted at scale. In simpler terms, they shut down public access to real-time observations, not because the data was uncertain, but because it was too significant to release without control. Meanwhile, internal analysis continued, and what scientists began to realize is that the bridge is not just transporting matter randomly, it appears to be directing it with precision toward a specific destination, Mars. The trajectory is not coincidental, it is aligned. Repeated measurements confirm that the plasma bridge is maintaining a stable directional link between 3I, Atlas, and Mars, adjusting continuously as both objects move through space. That means the system is not static, it is adaptive. And that leads to an even more unsettling conclusion. If a structure can maintain a stable pathway across millions of kilometers, adjust for orbital motion, and transport mass with controlled acceleration, then it is operating at a level of coordination far beyond natural processes. At this point, some researchers have begun to describe the system in computational terms, not as a cometary event, not as a plasma discharge, but as a dynamic network, a structure that processes energy, regulates flow, and executes directional control. However, this interpretation remains controversial because it implies intent or designs something science is cautious about attributing without overwhelming evidence. Still, the behavior continues to reinforce that possibility. Because the motion of the mass inside the bridge is not chaotic. It is structured, predictable, repeatable, and most importantly, it is synchronized with the electromagnetic pulses first detected days earlier. Then came another unexpected observation. As the mass continued accelerating, its interaction with the plasma field began to change. Spectral readings showed subtle shifts in energy density along its path, suggesting that the bridge is not just transmitting force, it is modifying the medium itself in real time. This means the corridor is not passive. It is actively shaping the environment it operates within. At this stage, even the most conservative interpretations struggle to fully explain the data. Because if this were a natural phenomenon, we would expect decay, instability, or random variation. Instead, we are seeing consistency, order, and directional control, which brings us back to the central question: what is the purpose of this system? Because the more we observe it, the clearer it becomes that this is not simply an emission from a distant object. It is a functioning structure with behavior that resembles engineered transport. And whatever is inside that bridge is now less than 30 hours away from entering the Martian system. That means the next phase is not theoretical, it is imminent. At this stage of the investigation, the focus is no longer just on 3I, atlas, or the structure it has created. The real attention has shifted to what is approaching Mars inside that plasma corridor and what happens when it arrives. Because the data coming in now is no longer theoretical, it is time-sensitive, and it is changing in real time. Let's continue exactly where we left off. With the 12,000-ton mass accelerating through the plasma bridge, tracking systems across multiple agencies confirmed a stable trajectory toward Mars. But what began as a controlled transit has now started showing signs of dynamic adjustment. The object is not simply moving forward anymore. It is being guided with increasing precision. As the system approaches the Martian orbital zone, instruments recorded a tightening of the beam's structural integrity. The plasma corridor itself appears to be adapting, as if reinforcing its own pathway ahead of the incoming mass. That detail alone forced scientists to reconsider their assumptions, because a natural system does not typically reorganize itself in anticipation of an object's arrival. But this one appears to be doing exactly that. At approximately T-36 hours before closest alignment with Mars, NASA's Deep Space Network recorded a noticeable change in the pulse frequency of the beam. The interval between emissions decreased again, shifting from 23 seconds down to 11 seconds, and then into a more complex sequence involving prime number intervals. Each shift was precise. Each change was consistent across multiple observation platforms, and each one correlated directly with increases in the acceleration of the mass inside the bridge. In other words, the system is not only maintaining control, it is refining it. Then came a development that escalated concern across multiple agencies. Telemetry from ESA's Gaia spacecraft confirmed a slight but measurable course correction in the overall structure of the plasma bridge. The alignment between 3I, Atlas, and Mars adjusted by approximately 0.08 degrees. That may sound small, but in interplanetary terms, it is enormous. It means the system is actively recalibrating its trajectory in real time. A natural comet does not adjust its path with this level of precision. Orbital mechanics are influenced by gravity, radiation pressure, and momentum, but not by controlled directional correction. And yet, here it is. Adjusting, responding, compensating. That realization led to a shift in how some researchers began to describe the phenomenon internally. Instead of referring to it as a beam or a jet, certain teams started using more neutral terminology, a structured transport system, because that's what the data increasingly suggests. A system capable of maintaining a stable corridor across millions of kilometers while also actively guiding a massive payload through that corridor with synchronized acceleration and directional correction. Then came another critical observation. As the mass approached closer to Mars, spectral imaging from multiple observatories revealed changes in the energy distribution along the beam. The plasma was no longer uniform. It was forming layered structures, regions of higher and lower density, that appeared to respond to the position of the traveling object. This indicates feedback. The system is not only sending energy, it is reacting to it, and that changes the entire framework of interpretation. Because feedback loops are not typical in passive astrophysical phenomena, they are characteristic of controlled or self-regulating systems. At this point, NASA, ESA, and several partner observatories initiated emergency coordination protocols. Within hours, a Level 1 deep space data blackout was imposed across civilian-accessible observation networks. Public-facing telemetry streams were restricted, not because data was uncertain, but because the implications were too significant to release without structured analysis. Internally, the language used in reports also began to shift. What was once described as a plasma anomaly was now being referred to as a dynamic interplanetary conduit, a term that avoids assumptions but acknowledges structure, directionality, and function. And then came the most concerning observation yet.